Something that I do some research on is earthquake prediction. And there are people who claim to be able to predict earthquakes based on all kinds of phenomena, ranging from how long back in the days when we had newspapers and read classified ads in newspapers, people had lost pet ads in the newspapers. And some scientists have looked at things like how long are the lost pet ad columns, like how many pets went missing, just before earthquakes, right? As sort of evidence that animal behavior predicts earthquakes. And they sort of look at associations between the length of the lost pet ad columns and earthquake incidents, earthquake occurrence. Some people have looked at things like the web building behavior of spiders, or the activity of cockroaches, which they put in some box where they measure the electrical activity associated with them walking on some touch plate. Okay, I mean, there's some really wild things that people have looked at to try to predict earthquakes. Though some people are looking at things like the chemical composition and temperature of groundwater in wells. They're looking at radon gas. They're looking at the movement of the ground, certainly. They're looking at electrical signals in the ground, electromagnetic waves, looking at the resistance of the ground across faults. Some of these have physical theories behind them. Some of them are just utterly empirical. But if you look at the predictions that have claimed success, one of the biggest groups doing this is a group in Greece, and they're using electrical signals. And if you actually look at what they're doing, you look at how successful they are, they tend to be more successful if you run the time axis backwards than if you run the time axis forwards. Okay, so what you find is when they issue a prediction, it's pretty likely that there was an earthquake a little while before the prediction. It's a little less likely that there's an earthquake a little while after the prediction. So what's happening, right? Well, everybody in California knows that earthquakes have aftershocks, right? And so if you were going to guess when an earthquake is going to happen, a pretty good guess would be right after another earthquake. Okay. A very good algorithm for predicting the weather is, what's tomorrow's weather going to be like? It's going to be like today. Right? So the sort of first order weather prediction is predict that tomorrow is going to be like today. You'll be wrong some fraction of the time. There are places where that's phenomenally accurate. Right? There's places where that actually works better than the official predictions do. I had a student study this in a graduate course not that long ago. Okay, so to first order, predicting earthquakes the same way will do a pretty good job. If there was an earthquake yesterday, predict that there's going to be one today. If there wasn't one yesterday, predict that there won't be. It actually works pretty well, but it's not really giving you a whole lot of extra information. Right? You sort of, okay, so if you wanted to evaluate how effective earthquake predictions are, you'd probably want to compare them not to sort of no prediction at all, but to a really naive prediction that does something like that. If there was an earthquake yesterday, predict that there will be one today. Okay? Because that's exploiting the clustering of earthquakes to tell you something. All right.